Hi students, problem number 14. Two bar magnets of equal magnetic moments M each is placed as shown below. The resultant magnetic moment is to be determined. Now you can see two bar magnets are placed here. The angular separation is 60 degree. The first magnet, which is held horizontally, is having its magnetic moment in this direction from south to north. So it is M1. Like that, the second bar magnet, you see the south pole is on the right side and the north pole is on the left side. So the direction of the magnetic moment, is always from the south pole to the north pole, is it not? So its magnetic moment M2 is from south to north. Now, though in this diagram the angle between the two bar magnets is shown as 60 degree, but the actual angle between the magnetic moment M1 and M2 is not 60 degree. So for that we have to rotate this south pole through 120 degree. So this remaining angle 120 degree I have to rotate. Then only the south and north will be aligned along the first magnet. So the actual angle between M1 vector and M2 vector is not 60 degree, it is 120 degree. Understand? So in this picture it is given M1, the magnetic moment of the first magnet as well as the second magnet, both is equal to what? M. So M1 is equal to M2 is equal to M itself. And the angle theta between the magnetic moments M1 and M2 is 120 degree. So theta is equal to 120 degree. Okay, suppose this pole instead of south, here north is given and here south is given, then in such a situation the angle between M1 and M2 will be equal to what? 60 degree. But since the polarities are reversed, the angle is not 60 degree, it is 120 degree. Have you understood, students? Okay. So theta is equal to 120 degree. Now the resultant magnetic moment, let us take the resultant magnetic moment is M resultant. Okay, M resultant. So this is equal to square root of M1 square plus M2 square plus 2 into M1 into M2 into cos of theta. So we are going to substitute M1 is equal to M and M2 is equal to M and theta is equal to 120 degree. Therefore, M resultant is now equal to square root of M square plus again M square plus 2 into M into cos of 120 degree. So this is now square root of M square plus M square is 2M square plus 2 into M is another 2M square into cos 120. So cos 120 is equal to cos of 180 minus 60. Is it not that? So this is minus of cos 60 product. So this is now equal to square root of 2M square plus 2M square into cos 60 is 1 by 2. So into minus 1 by 2 So this is equal to this 2 and 2 get cancelled. So this is now equal to square root of 2M square minus of M square. So this is equal to square root of M square. Therefore, M resultant is equal to square root of M square is M. This is the required answer. So what is asked here is the resultant magnetic moment of this arrangement is found to be equal to M. So option A itself is the right answer. So option A, that is resultant magnetic moment M resultant is equal to M, is the correct answer. This type of numerical problem should be carefully handled. Suppose if the south and north poles were reversed, means as it is theta should be taken. Since here the north and south are in opposite sense, the angle between the two magnetic moments is 180 degree. Otherwise it is very simple numerical problem only. I hope you must have understood well. Fine.